Hi students, let's look at this question here, which is taken from the year 2013 RVHS promo question 3, which is a quite interesting question here. So the diagram shows the sketch of this curve here, y minus 1 square equals to x, square root x square minus 1 with the vertex of 1, 1. So this is the vertex here, means this is sort of like the end point here. Now right now the equation of the graph when c is translated 1 unit in the negative y direction. So in this case here, 1 unit in the negative y direction, just replace y with y plus 1, right? So if you want to translate 1 unit in negative y direction, just replace y with y plus 1. So this just replace here. This will just be y plus 1 minus 1 square equals to, so I just replace y plus 1. So it's x square plus 1. This is y square equals to x square plus 1. Okay, so that's how you do the first part there. So let's look at part 2. Part 2, the shaded R bounded by C, a vertical line XA is rotated through pi radians about y equals to 1. Now pi radians means 180, but because R is actually a full circle here. Now first of all, we know y, okay, so y equals to 1 is over here, so meaning in this vertex here. Alright, we want to rotate about this y equals to 1 line, which is about here. Okay, and pi radian is because this is already full on both ends. So when you move 180 about it, it will be a full circle on one end here. Alright, so it looks something like that because this is actually, let me show you, this is let me just show you this part here. View. Okay, so this is already surface. So if I were to rotate this 180, so I just need to rotate this 180. You see that? So if I, this is no, so I rotate this 180. You see this is 90 degrees. Then it will just be full circle because it's a whole end there, which is making it a full circle, right? So essentially, this is the volume that I'm looking at. But the problem now is, we do not have y equals to 1. So we need to just translate everything down to the x-axis, which is what we done in the first part, right? So this case here is quite straightforward. We move the whole graph down, okay, by 1 unit. So essentially, we move this by 1 unit. Just now, we move down by 1 unit. And once we move down by 1 unit, this would then be 1, 0. This will be x-axis. Okay, so it just be a here. Great. So it's just a normal integration because you just want to rotate R about the x-axis now. The new equation that we found. Okay, we'll rotate it down. So once this is done, we're going to do part 2. So this is required volume. This will be pi. We're going to do from 1 to a. Okay, 1 to a. And this is y square dx because rotate about the x-axis, the new x-axis here. You use this new equation, okay? New equation because we put everything down 1 unit. So this will be pi 1 to a x over x squared plus 1 dx. Actually, we can integrate this straight away, but they ask us to use the substitution. I'm not sure why. It's quite lame to be honest, but okay. Let u be square root x square, is it minus 1? Okay, so in other words, the u square is equal to x square minus 1. So this is important. Then once this is done, we need to, if you're using substitution, we need to change this to du and this whole function here to du as well. Just slowly. So du here will just du dx will just be half x square minus 1 minus half, and this is 2x. This is x over square root x square minus 1. Okay, so once this is done, we just let dx is equals to x square minus 1 du. So in other words, dx is equals to square root x square minus 1 over x du. Then we just attach this dx behind here, but a lot of times you're not allowed to write this, so you just erase this once you are done with this. I I always see this in university textbooks, so I think it's fine to leave it there, but certain schools would not allow you to do that. So just remember that. So this, just grey it out if you want to. So just grey this out. Okay. Alright, once done, we have got this as x, which is actually x squared plus 1. So it's always good to just substitute in first and see what could be cancelled. So this is square root x squared. Hey, what is this x squared? Oh, I wrote wrongly. This is minus 1. This is minus 1. Okay, so that's pretty okay. Then we get this is minus 1. It's minus 1. Alright, then this will be minus 1 over x du. Oh, you see that this could be cancelled away. And this case here will just be pi x squared minus 1 du. Okay, x squared minus 1 is u squared. Now take note, this is another one which you need to take. This is a, you need to change. So when this is dx, this is actually x equals to a and x equals to 1. So you need to change this to u. So when x equals to, just the boundary condition, take note. A lot of times students forget that. So when x equals to a, u equals to square root a squared minus 1. When x equals to 1, u equals to 0. Great, so this will be 0 and a squared minus 1. Okay, a squared minus 1. So there you go. You change everything. This is a squared. Now take note, this needs to be changed to a u squared as well, because we are integrating with respect to u. Maybe I just write this in blue. Is 0. Okay, so then x squared minus 1 would be, x squared minus 1 is u squared. So this is u squared. Okay, this case here will just be pi u cubed over 3 a squared minus 1, 0. That's pretty okay. There will be pi 1/3. Then this will be a squared minus 1 to the power 3 minus 0 cube. Okay. I think that's it. We will get the answer as pi over 3 a squared minus 1 3 over 2 cubic units. Okay. So let me just move this about. Okay. Yep. So that's how I do this question proficiently. If you have any questions at all, please let us know. Keep practicing and I'll see you in the next question.